Hello there, ATS EVS 533 students. Dr. John Schrage here, and I am welcoming you to our third module of the course. Hope you had a good break, and we're going to be now starting to talk about the use of models to understand the climate system and to make forecasts of the climate system and so on. Now, I always get a little bit worried about when we hit this kind of material because I get it that this is very, very new to everybody in the class. Nobody in this class presumably has a whole lot of experience with regard to designing the experiments that are used to make long-range climate simulations or working with numerical models. In fact, the very term numerical model might be new. We're going to have to talk about the kinds of initial conditions and boundary conditions that are used as input to the models and how that's different from and yet sort of the same as what we do to make like weather forecasts from day to day that busy meteorologists do. So we're going to have to talk about all that stuff. And we're going to see how we're going to be using, here's another powerful vocabulary word for you, ensembles of climate models to get a sense of the range of possible outcomes of the future. We're going to learn about how the IPCC set up the special report on emission scenarios to create predictions of the future in terms of like social justice, economic changes, new technologies, disruptive technologies, and so on. Why? Why do they need to know all that kind of stuff to do climate modeling? Well, it's going to be about establishing the boundary conditions like greenhouse gas concentrations and so on. We're also going to learn about how they're gradually replacing that strategy with the somewhat better idea of the RCP pathways, I always forget what it stands for, the representative concentration pathways, which is another way of representing what the future concentrations of greenhouse gases and aerosols and so on in the atmosphere could be. It's pretty cool stuff. Then we're going to start seeing, well, what do those models actually tell us about the near-term climate, like between now and the middle of the 21st century, as well as long-term climate. I mean, out to even 1,000 years from now, we can make meaningful ideas about what we think the climate system is going to look like at that point in the future. Cool. We're also going to talk about disruptive things that could happen in the climate system, abrupt climate changes, catastrophic stuff like collapse of the West Antarctic ice sheet, or disappearance of Arctic sea ice, or catastrophic loss of methane clathates from the bottom of the ocean. You're going to learn all about that kind of stuff. Or collapse of the Atlantic meridional overturning current, or catastrophic loss of forests. Awful, but cool in a climate science sort of sense of way. So we're going to cover a lot of material here that's probably very new to you. And as a consequence, we kind of have a smaller number of lectures this time, just because I get it that between now and the next exam, you're going to be learning a whole lot of things for the very first time, whereas some of the things that we've seen before might have been partial reviews from how you took Introduction to the Atmospheric Sciences and so on, or maybe even the climate change course, or other things in your environmental science curriculum. Anyway, so we're going to be seeing a whole lot of cool stuff in this module, and obviously at any point along the way, please let me know if you have any questions, and I think you're going to be learning a lot of very cool 500 level material here. All right, let me know if you have any questions.